For a typical galvanic cell, I mean electrochemical cell, a cell reaction is given. If a cell reaction is given, how to write a cell notation for the galvanic cell? How to represent a galvanic cell? Number one. And how to find the number of electrons? How to find number of electrons? So, but why finding the number of electrons in the cell reaction? Because we know the charge. If we know the charge, we can find easily cell potential, standard cell potential. That is the main purpose. So what is a typical cell reaction? A typical cell reaction is redox reaction. So what is a redox reaction? Here I am taking is nickel reacting with salt solution. What is a salt solution? Is Ag plus aqua solution. The nickel metal placed in the silver salt solution, and it changes into nickel plus 2 aqua solution to Ag metal solid is produced. This is the cell reaction. So whether the cell reaction is spontaneous or not, so whether that galvanic cell in which this cell reaction is operating, functioning or not, we'll check now. So if the cell potential, standard cell potential is a positive, definitely this reaction can make the cell to work. If the cell potential, standard cell potential is a negative, the reaction in which cell is present, the cell doesn't work. So if you look at this reaction, cell reaction or redox reaction, immediately what we should do means we should divide this reaction into two half cell reactions. Into two half cell reactions we should write. Two half cell reactions we write. So first, cell half oxidation of cell reaction, oxidation half cell reaction, and another one is reduction of cell reaction we should write. Okay, now number one, number two, oxidation half reaction we should notice, reduction half reaction we should notice. In this redox reaction, which species getting oxidation? And now observe this. This is pure metal, this is ion. Now nickel getting, so charge difference how much? 0, and 0 to changing to how much? Plus 2. That means nickel getting oxidation. You write the reaction of oxidation, nickel solid changing into nickel plus 2, losing how many electrons? Nickel plus 2 means losing 2 electrons, which is oxidation. At the same time, silver plus ions changing into silver metal. Here how much charge is present on this? Plus 1, and changing into metallic atom. So how many electrons? 1 electron. But nickel losing how many electrons? 2 electrons, where silver is gaining how many? Silver ions getting reduction, gaining 1 electron to form metallic silver. So gaining 1 electron, but nickel is providing how many electrons? 2 electrons. So you write Ag plus gaining 1 electron to become Ag metal atom is aqueous. This is solid. This is reduction half reaction is happening, but electrons in both equations you observe, nickel losing 2 electrons and silver gaining 1 electron. Can balance, divide, multiply this equation with 2. So then nickel plus solid, and multiply 2 means here 2Ag plus equal to nickel plus 2 and 2Ag is changing. That means 2 electrons and 2 electrons are cancelled. So this is the redox reaction we are getting. That means nickel getting oxidation, silver getting reduction. And hence this is a redox reaction. So how to check whether this reaction is spontaneous or not? Then we have to note down the electrode potential differences. Electrode potential differences of cathode. What is a cathode here is, so E cathode electrode, standard electrode potential of cathode is equal to how much? Cathode is, so here we write Ag plus changing into Ag. For reduction potential of, standard reduction potential of silver ions is positive value 0.8. You can see in electrochemical series where silver is lying under the copper, hence the value is a positive. And similarly, you write standard reduction potential of nickel to nickel, how much it is? Minus 0.25. It will be above the copper. Negative value indicate easily undergoes oxidation. So now you write the formula, standard cell potential if you want to derive, E naught cathode, reduction potential of cathode minus E naught reduction potential of anode. E naught means reduction potential, standard reduction potential of cathode, how much? So 0.80 volts minus here standard reduction potential of anode is how much? Minus 0.25. So minus plus. So here value how much? 0.80 and minus 255. So 1.05 volts, which is a positive value. 1.05 volts is the electrode potential difference of two half cells, which is the standard cell potential. That means, so the cell in which this redox reaction is taking place, it is, so it can work, it can perform its operations. That means that cell potential value, standard E cell potential value is a positive, means that cell can work, it can operate easily. Standard cell potential is a positive, cell definitely can work. If the standard cell potential is negative, the cell doesn't work. That means if you take silver as anode and nickel ions as cathode, then the sign of convention you get negative, cell doesn't work. So this is when the cell reaction is given, and from this we can calculate number of electrons here, number of electrons calculated, and if you know the number of electrons, we can so get the cell potential also. We can relate with the delta G and cell potential and the charge. So this is, and for this spontaneous redox reaction, so how to represent cell notation, galvanic cell notation. Now here is nickel metal placed in nickel salt solution, aqua solution here. Let us take concentration 1m and separated by salt bridge, silver ions, aqua solution, 1 molar solution separated by silver metal solid. So this is cell notation. galvanic cell representation.